Hi there, this is video 1.7, Proofs, Introductions, and Vocabulary. So this gets exciting because we're going to be able to do some math and show that a case, whatever our conjecture is going to be true in every single case. We don't have to sit there and do 40 different examples looking to see if this is ever going to work for us. So pretty cool. All right, so a proof is a mathematical argument showing that a statement is valid in all cases and that no counterexamples exist. Okay, proofs are how? Inductive reasoning, because that's where we start, is shown to be valid or correct in all cases and that no counterexample exists. Okay, so this makes deductive reasoning way more powerful than inductive reasoning. Okay, and how's a proof related to conjecture? Well, once you prove a conjecture, it becomes a theorem or a law that can be used to prove other things. Pretty darn cool. Okay, so it's not trying to go through every possible case, whether it's going to work or not. It's like, okay, this is always going to work. And I get excited in math when we have things that always work. But before we get to that, we need to do a little bit of vocabulary, because a lot of these proofs are find the sum of two even numbers is even, or prove that the difference between an odd and an even number is odd. A bunch of stuff like that. And we need to make sure that we all have the vocabulary so we're talking about the same thing. Okay. All right. So sum. Hey, you know what? How about you turn off the video? I bet you can do most of those without my help. All right. I'm going to trust you did that. Sum is the answer when you're doing addition. Oops. I should put there. Answer 4. Well, that got all messy. But I think you guys can see better when I use my pen. Difference. Answer for subtraction. Okay, I think we used that already. Product. Answer for multiplication. Quotient, well, what's left? That must be answer for division. Okay, don't worry about this. This actually belongs in the next video. I changed my page around. All right, let's go down here and look at prime numbers. We'll come back to these in a sec, and that will also explain why there's a big map at the bottom of the page. Prime numbers, numbers. That have only 2 factors, 1 and the number. Okay, so 1 is not prime. Okay, I looked that up. By definition, 1 is not prime. It's because there's some very fancy rules and proofs in mathematics that don't work if 1 is considered prime. So mathematician just said, yeah, you know what, 1's not prime. And then all their stuff works. I'm sure you can Google and get more information about that. Okay, so 2. If you think about it, 2 is prime because if you try and factor, you get 1 times 2, and that's it. 3 is prime because you factor that out, 1 times 3. That's it. That's all there is. But when you get to 4, it can be 1 times 4 or 2 times 2. So 4 is not prime. And in fact, it's composite. And I know that because I learned that a couple of years ago. I didn't know. I just called it not prime, but the official term is composite. All right, so natural numbers and whole numbers. Natural numbers begin at 1, 2, 3, boop, boop, boop. And whole numbers begin just a little sooner. 0, 1, 2, 3, dot, 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 and so on. It keeps going. Maybe you can remember there's no one whole, and there's a 0 over there. They kind of look the same. Okay. So, confession time. I saw this thing on Pinterest and it appealed to me on MathGeek. If you put your address somewhere on this map, okay, I'm going to say, I think that's a little off, but let's pretend that's Regina. Actually, let's pretend that's 265 Albert Street, because that's my home address. Okay. Let's go up here. Boop. 265 Albert. So that is enclosed in a bigger circle, which is like Regina. Okay, so remember, 265 Albert is not the only address in Regina. There's a lot more. But if I say I live in Regina, I might live here, I might live somewhere else, but it's there. And then, what's next? Well, thank goodness we live here. It's pretty easy to draw. There's Saskatchewan. And we live in, yeah, I know, a lovely big country here. All right, so where am I going with this? And one other question. What's this? I hope you know that. Australia. So where am I going? These are like natural numbers. It's the smallest unit, smallest grouping we have. If you take all those natural numbers and you add a 0 to it, you get whole numbers. And if you take the whole numbers and you add the negatives onto it, you get a bigger grouping, which are the integers, right? Positive and negative numbers. And if you go one more layer, even bigger, you get the rational numbers. Right? Those are the ones that include all your fractions and decimals. So they're the terminating and repeating decimals. And then way over here, just like the irrational. That's like pi and root 2 and all that crazy stuff that we don't use that often, but you know, it's there. And the whole thing, this whole big box, is like real numbers. It includes all of them. I hope that cleared it up a little bit for you with the Venn diagrams and stuff, right? Because the important thing to remember is if you're talking about integers, it includes those other two. Just like if you live in Saskatchewan, it's going to include people that are living in Regina and people that live in 265 Albert Street. All right, have a great day.